next project we have up, Coda. So you get an update from Evan Shapiro. There he is. Yeah, happy to have you here. Got to learn more about what's going on with Coda. I know a lot of developments on the testnet front, moving them forward to potential mainnet launch point later this year. So
yeah. So I want to start by kind of just saying, like, let's go back to fundamentals on this. Like, what are we actually trying to accomplish with cryptocurrency, with blockchains? Like, what's the whole point of this? So our answer to that's been Coda, and I'll tell you about that in a sec. I'm Evan. I'm the CEO of O1 Labs. We've been building Coda for like 3 years now, and let's just jump into it. So here's a proposal for what I think the goal should be. I think networks should be user-owned. They should scale to everyone. And they should enable programs that basically provide like privacy, verifiability, scalability, good things that cryptography can bring us that will actually like hopefully bring improvements in people's lives. If we think about networks today, they kind of fall short of this. Networks are owned by people that have lots of capital and run validators, or people that have lots of mining hardware. As we heard in the last talk, that they don't really scale. Like they're notorious for being bad at scaling. They don't really enable privacy. They are reliable, and for the most part, the amount of compute you can put on these chains is pretty small. It's very expensive to do even small amounts of stuff due to that. So if we're going to solve these issues, here's what a proposal for what I think we would need. We need decentralization and scale. We need our apps to be private, verifiable, and also scale compute on that end. And we're going to need a way to get interested users ownership in the protocol. So not just through capital, but I think like all contributions should translate into ownership somehow. And I'll be telling you about our solutions to these things, starting with the first two, and we'll loop back to the last one at the end of the talk. But yeah, so how do we achieve these decentralization and scale, privacy and verifiability? Our solution has been to build the whole protocol on top of ZK Snarks. So these are cryptographic proofs that verify the output of a computation, optionally hiding some of the inputs for privacy. So when someone gives you a proof of a computation, you don't have to run the computation yourself, you can just check the proof. And that leads to efficiency. And because they can hide some of the inputs, any sensitive information, you get privacy. The impact of building the protocol in ZK Snarks is you can get a full proof of the current state of the blockchain in just a few kilobytes, independent of any throughput, so decentralization and scale through that. And we get snaps, so we get native support for private and verifiable snarkified apps on top of Coda. So let me tell you a little more about how this actually works. In a usual blockchain, you have a block, and what do? At some interval, you add more blocks to it. You add more blocks, you add more blocks, you add more blocks, and before you know it, you have a really long blockchain that is still growing and is already huge. So this is a challenge for a lot of reasons. You have to now download and store this whole thing. You have to synchronize to it. And actually, when you perform any new transactions, they have to go onto the blockchain, which makes it even harder to use over time. And an alternative to this, maybe, let's think about it using ZK Snarks, is, so we have our Genesis block and a block on top of it. What we can do instead of just extending this is provide a proof of the history of the chain instead of actually requiring everyone to download it. So we replace the Genesis state with a proof. And the proof proves the same computation that we cared about originally, that the history was valid, but the proof is very small. The proof's only a few kilobytes, and it's equivalent to the computation that we originally talked about, checking the whole chain. And now when we extend the block, what do? We take the existing state and we put that inside of a proof. And so now what we're doing is, instead of extending the blockchain, we are extending the proof recursively so that we have a constant size chain. So this is cool. Now we have whatever the current state of the blockchain is at the front, and we have a proof representing the whole history of the chain. So what does that get us? Well, the proof of the chain and the proof of an account is very, very small now, about 13 kilobytes, and it certifies the entire history of the chain. So now what we can do is we can really get access to the chain trustlessly from any device. We can get access on computers, on phones, on web browsers, an Internet of Things device, like whatever. Whereas other chains would require many increasing resources to verify the current state, which both creates an initial high cost and makes it harder to run nodes over time. So the set of nodes that are performing consensus on the network that are fully verifying everything shrinks. In contrast, if we have the approach where everyone verifies a ZK Snark, as we add more members to the network, Every node's fully verifying everything. It's very robust. And there's no need for anyone to delegate any trust to any like privileged parties in the system. Everyone can just get the full proof themselves. So it's good for robustness for decentralization. It's also great for scale. So now that we have this proof of history instead of the history itself, we're only limited by how quickly we can add more snark proofs into the chain. How quickly we can kind of shove snark proofs into this, master snark proof. And we can do that pretty quickly, it turns out. So we're only limited by network bandwidth and the number of active accounts on the current state of the network. And this is also cool because if you look at any transaction, you can attach compute to it, and then you can kind of recursively verify compute without burdening the main chain. The main chain can say, hey, this huge computation that would have taken me 1,000,000 years for everyone in the network to verify, oh, cool, I know it's correct, but I don't have to actually run it myself. The whole computation is recursively verified, not directly verified. Same guarantees, but way more efficient. So what are these computations? We call them snaps. And they're basically the same as decentralized apps, but they provide full verifiability, scaling, and privacy. And these are cool features to have because now we can make existing computations more aligned with our users. And we can unlock new computations that would be too sensitive to perform today. And not to mention just putting more compute on blockchains through this recursive scheme I mentioned earlier. So some examples of this, we can do things like bringing public blockchains to enterprises without any privacy drawback. For example, let's say an enterprise wanted to put a database of KYC, identity verification, onto a blockchain. Right now, that would probably have a lot of privacy concerns pretty clearly. But what we can do instead now is produce a proof of those identities. And then what I can do is I can come along and I can prove that I have a valid identity in that database without revealing who I am, which is great for interacting with any smart contracts that require some proof of identification. You can also do things like verify the authenticity of a computation. For example, proving a photo is authentic using Snarks. So you could have a proof that this photo was signed by the camera's hardware, and that then only limited edits were performed to it. Things like cropping, changing the color, nothing that would actually make it a doctored photo. You could also do things like more scalable, more private DeFi. So things like DeFi loans based on private off-chain credit scores is possible. You can have a smart contract that has some criteria, and you can prove that you've met exactly that criteria, and you don't release any other information about yourself, just the criteria to get the loan. We can also think about things now like web apps without permission middleware. So right now, if you want to interact with cryptocurrency on a browser, you need to find someone to trust, usually like an Infura or Infura itself. And you ask them, hey, what's the current state of the chain? What are the balances? What's cool about this approach is your browser can now directly download the proof. It doesn't need any third party. It can peer-to-peer figure all this stuff out client side without any other one in the middle. So that's all cool. The way that this is all done is we have block producers that perform consensus, and they stake Coda to produce blocks. And for that, they receive inflation. They receive 12% the first year, and then fees. So it's also really easy to run one of these things because you just have to download the proof and the current state. You don't need to download the whole history. It's very consistent difficulty over time. We've also designed the consensus to support an unlimited number of stakers. And we're doing our best to make it accessible to anyone through a program I'll mention later in the talk, the Genesis program, which has token grants. We also have snark workers. What these do is they create the snark proofs that compress the chain. So every transaction needs a corresponding snark proof. These are the ones that make the snark proofs. What's cool about this also is that even though the system for consensus is proof of work, this gives a way you can point your computer at Coda and perform compute and get Coda tokens that way. So similar to proof of work, you can point your computer at the Coda network and start earning Coda tokens for helping compress the chain. So the account model for this is it's account-based. You can send payments, you can make and send tokens, and you can also store data. You can optionally load or verify a snark circuit in every account. And what that lets you do is set rules around how data gets updated, who can send payments from the account, who can make tokens. So that way you can get these snaps I mentioned earlier, so you can attach accounts basically to applications. And I want to share one more cool idea on this. Right now, we have all these entities that we trust for the world to basically work. We have banks following regulations, companies balancing their books, countries counting votes correctly, organizations submitting photos that shouldn't be doctored. And right now what we do is we trust these entities that they're actually doing what they say. If they say, hey, we're following regulations, we trust them on that. But as we've seen, this works for most of the time, but every once in a while, someone either intentionally or unintentionally messes this up. They make a mistake, and that can be very costly. And even if no one was trying to be malicious, like it's easy to make mistakes, easy to miss what you're supposed to be doing here. One possible cool idea here is when someone says, "Hey, I'm following regulations," what they're really doing is they're saying, "Hey, I followed some computation. I followed some computation and I got a result. Trust me on that." If we think about it that way, what we can do is instead of just having these people say, "Hey, trust us," they can submit a proof of the computation that they did. And then they can say, "Look, like here's a proof I actually did the thing I said I was doing. And you can trust me on that because I'm providing a proof of it." What I think is even cooler here is the possibility of kind of combining all of these together into one master snark. And then we would have the property that we would have this one snark that all these different organizations could interoperate on. They would all be able to trust each other really, really well because they actually see proofs computationally. And also we as individuals could look at this big snark and we could say, hey, things are actually doing what they're supposed to do. I can actually check that and I know quickly without looking at everyone's data or their sensitive data that everything is happening as it's supposed to, which seems pretty cool. So if we want to do this, we definitely don't want any particular entity to control this process. But fortunately, we have cryptocurrency for that, so we can do censorship-resistant access to this system. So Coda today is in public testnet. It's pretty easy to install on most platforms. We have a growing community, over 400 people participating in our testnets, including over 300 stakers, and we're currently onboarding Genesis members to the program. So the Genesis program is basically our way of providing an on-ramp for all contributions, not just people contributing capital, but people that just are actually going to make this thing work. They receive a distribution of 66,000 tokens, and we're aiming for over 1,000 members on Mainnet. So this equates to 66 million tokens, and there's going to be 1 billion tokens distributed in total. So once it's fully diluted, this is 6.6% of the fully diluted token distribution. It's even larger at Mainnet launch because it's not diluted yet. So if you want to check that out, you can go to codaprotocol.com/genesis to learn more about the program. If you want to just see our community and check out our protocol development, it's all done on our Discord. There's a short link here, bit.ly/Coda Discord. You can check it out there. So yeah, if you are excited by any of this stuff, just come check out what we built, and yeah, we can explore what we can build with Coda and Snarks. So that's all I have for presenting. Let me know if any questions.
Hey. Great, thanks for the presentation. That was fantastic.
Thanks.
Good clip too. I'm really curious. So Coda's using a proof of stake protocol. To jump right into questions, how does it kind of differentiate itself from other stakers? Because you mentioned that it would allow anyone to stake. Is there a validator program alongside of it, and how does that?
Yeah, I think it distinguishes itself in both the ease of staking. We've made it so you won't have to download the whole history of the chain. You just download the current state, which is really small, and you can run on a regular computer. And we've designed the consensus to support an unlimited number of stakers. And that we have the Genesis program to make it so you can actually get onboarded to the protocol, have a stake of tokens, actually be staking without only putting in contributions to the protocol. If you contribute, you can actually become a staker. So we want to make it really accessible to everyone.
That makes a lot of sense. Definitely a great way to onboard a lot of people onto the platform and contribute to the platform. So I have a couple other questions here. How do you see Coda fitting into the ecosystem with a bunch of other competitors? Because you have a very crowded smart contract market.
Yeah, totally. I think there's maybe 2 places that I'm particularly excited about. The first is just, I think making the core protocol itself a snark, just is quite the improvement, I think, for a lot of the technical challenges the space is facing right now. There's a lot of complexity to sharding, challenge-based layer 2 in general, and this is just a cleaner solution. The other thing I'm really excited about is just the possibilities that Snap brings. It's not going to be things are not going to work if everything is just on public blockchains, not interoperable. It's oh, a company wants to join a blockchain. Oh, here's all the sensitive information that had to go into my computations. I think you really need to have some mechanism of doing privacy really cleanly and allowing computation on all the sensitive information, and that's what Coda brings to the table on the use case side.
Excellent. And I guess kind of building off of that right there, Jonathan would like to know, so tech sounds incredible. Real talk, is this a game changer? Why aren't more people talking about Coda right now?
I think they're starting to. We basically just been building it for the last 3 years, and we had a public test net out only late last year. So you know, the community's going pretty quickly, and like now's a good time to like get involved. But we're kind of ramping up right now to an actual launch, which I'm excited to see happen.
That's great, and kind of building off of that even more. So you mentioned that you're trying to get developers on board. Like, what is part of your plan to get them on board?
Yeah, so I guess I think about this kind of like more of like a grassroots kind of thing rather than like a top down, like, oh, we're just gonna make a ton of grants and like people do it. I think I would love to see happen is the Genesis, like development and development community come out of the Genesis program, and there's still being good incentives to build out these kinds of applications, but kind of being a collaborative effort as we go towards launch.
Excellent. I mean, it's definitely something to consider because, you know, there's a great way to bring people on board by throwing a good amount of incentives out there. But then they may not be as ingrained or as, you know, dedicated to that platform. And I think that's one thing, you know, Ethereum being early on, you know, definitely they pretty much had the control of the market right there, but they did a lot of organic work at the beginning, a lot of meetups to get developers on board. So they kind of have like that tight knit community. So I respect the organic approach.
I think it's the way to do it. Yeah.
Yeah. No, I think that's great. I love this question here. Is the tech easily copyable by any other major change, or is the roll-up strategy only reasonable when starting from scratch?
So it depends. So basically, the full system I've outlaid here is not easily copyable. You have to like switch out whatever your consensus, your base protocol out for a ZK Snark, which basically requires designing the whole thing bottom up to work well with ZK Snarks, which is not easy. What you can do is you can build layer 2 solutions that have some of the advantages. ZK rollups, I think, is like the most promising thing for this right now on Ethereum. And you do get like the ability to like say, here's like a single proof of scale, but the proof is not interoperable as well with like the rest of the ecosystem, and it's kind of like tacked on. So you have other like disadvantages for like development, for how far you can push it.